So, scientific approach to knowledge is empirical. That means it's based on observation and experiment. Hundreds and hundreds of years ago, it was more like philosophy. People sat around and thought about, well, why is graphite like it is, and why is carbon? And they thought about things, but they didn't experiment and make observations. So the scientific method is a process that we use to understand nature and its behavior by observing and conducting experiments, okay? The key factors: observation, formulation of hypotheses, experimentation, and then formulation of laws and theories. We're going to talk about each of those. Observations, also known as data. These are things you can observe. They may be with your five senses. They may require instrumentation. But there are things that you can observe. The color of something, how much it weighs. Descriptions about the characteristics or behavior of nature. There will be some history, especially in this first chapter. We'll talk about historical figures. I am not going to test you on that. I think it's important to talk about what these people did, but I'm not going to quiz you on the dates that Antoine Lavoisier lived. Okay, I don't think that's relevant. Antoine Lavoisier was a French scientist. Lived in the 1700s, a long time ago. He was interested in things burning. How many of you like to burn stuff? Yeah, it's like, okay, there was a bold hand. Yeah, I like to burn stuff. I like to burn stuff. Man, my kids like to burn stuff. Burning things is great as long as you do it safely and you're not harming others, right? I think that a lot of chemists are secret pyromaniacs. We like to play with fire. So he's looking at burning stuff, right? Think about burning a log in the fireplace. How is the log different after the fire has gone out? It's a lot smaller. It's like black and charred. It might be reduced to a pile of ashes. Can you use it over again to build a fire? Not if it burned completely. So something happened there to the log. Lavoisier was interested in what was happening in that process of burning. I think that's one of the things that's so fascinating about fire, right? It wasn't there and now it's there and then it's gone again. How does that happen? So what he did is he took objects and burned them in closed, sealed containers. And he'd weigh the container and the object, and then he'd burn the object, and he'd weigh the container and the object again, all sealed up. And what he found was that there was no change in the mass of that container after he burned it. That's not what we observe in the fireplace. Because in the fireplace, things could escape. It's not a closed container. So that was his observation. So you make an observation, and then you make a hypothesis. The hypothesis is a tentative interpretation or explanation. It's not really a guess, but we understand that it might very well be wrong. But it's our best idea of what is going on here. Why did I see what I just saw? So his hypothesis was that when a substance burns, it combines with something that's in the air. Now, if you go and read the detailed history of Lavoisier's experiments, he made some wrong turns at the beginning, but eventually he got it right. So when a substance burns, it combines with something in the air. We know what that something is now. We know that it's oxygen. You can't burn something without oxygen. They did not know what oxygen was back in the 1700s. So that was his hypothesis. In order for a hypothesis to be useful, it has to be falsifiable. It has to be testable. We need to be able to test it and find out if it's correct or not. So if the substance is combining with something in the air, then you could test this by perhaps trying to burn this without any air in the container. If your hypothesis is correct, then whatever it was that you've been looking at is not going to burn if there's no air. If it still burns, then that tells you that your hypothesis was not right. And so you do experiments to test the hypotheses. Experiments are highly controlled procedures designed to generate observations. So we're going to set up the experiment in as controlled a fashion as possible, so we eliminate any of the other factors that might be changing. And then we're going to look at what happens as a result of that experiment. It may support your hypothesis, may prove it to be wrong. If it disproves your hypothesis, then you can maybe just modify your hypothesis, or sometimes you realize, man, that was like way off base. I have to throw the whole thing out, come up with some other explanation. So any questions about those parts of the scientific method? That brings us to laws and theories. It's important to understand the difference between them. A scientific law is a brief statement that summarizes past observations, predicts future ones. Let's see, I didn't bring a marker today. I'll use, no, I don't want to use, oh, there's a marker. Okay, you've heard of the law of gravity, right? The law of gravity is a scientific law. What does it say? What goes up must come down, or things fall down, right? I mean, you can just state it extremely simply. So, law of gravity, if I hold out this Sharpie marker and I let go of it, what does the law of gravity predict will happen?
It falls to the ground.
Falls to the floor. Every semester, it does exactly the same thing. The law of gravity predicts what will happen. Does it explain why the pen fell? No, it just says that it will. Another example of a scientific law, the law of conservation of mass. This is a law that came out of Lavoisier's experiments. In a chemical reaction, matter is neither created nor destroyed. The total mass that you started out with is the same as the mass you end up with. You can't create matter, you can't destroy matter. Doesn't explain why or how that happens, just says that is what happens. So scientific laws come about when many people have observed the same thing repeatedly. It's not something that comes about on a whim, it's documented and established. But scientific laws are also subject to experimentation, and they can be proven wrong or modified because the experiment shows that, okay, that wasn't quite right. Now, there are laws imposed on us by government, right? And we can break those laws. The speed limit on Highway 99 here in town is 65 miles per hour. Can you choose to go 70 or 80 or 90 miles an hour? You can. Can you choose to violate the law of gravity? No, you can't. There's no violating it. Because scientific laws just describe how nature behaves, and there's no violating them. Are there penalties to attempting to violate the law of gravity? Yeah, you might break something or kill yourself. So that's a law. Law says what happens. A theory explains, okay? So you get several hypotheses that have been tested and confirmed, and they're about the same thing, and those can form into a scientific theory. Explains not just what nature does, but why does that happen, okay? So John Dalton came along a little bit after Lavoisier, and he came up with the atomic theory. And that explains the law of conservation of mass that Lavoisier established by proposing that matter is composed of small, indestructible particles called atoms. Since these particles are merely rearranged in chemical changes, the total amount of mass remains the same. So if we go back to the Lego analogy, you've got a set of Lego bricks, and you're building this little spaceship. If you take the spaceship and take it apart and make something else using all the bricks, does the mass of the bricks change? No. All the bricks you started with are all the bricks you have at the end, regardless of what you made them into. And that's what chemical reactions are like. It's the atoms rearranging, okay? So the mass can't change. You can't create or destroy matter. Theories are validated by experiments. Scientists tend to be somewhat skeptical people, and we like to prove other people wrong. And so it's fun for some of us to challenge theories. Well, I don't think that's right. And you devise some experiment and you try to poke a hole in someone else's theory. You can't prove a theory to be correct. You could prove it wrong, but you can't prove it correct because who knows, someone might come up with a discovery in the future that enables them to prove that theory to be incorrect. So when we talk about a theory, like atomic theory, we believe atomic theory to be true, but you can't prove it to be true. The best we can say is there's no evidence to suggest that it isn't true. Sometimes people say, oh, well, that's just a theory. Well, in science, it's not just a theory. In everyday life, we use the word theory a little bit different. Oh, that's some harebrained scheme that somebody came up with. No, in science, a theory is as close to truth as we get. Theories can also be used to predict what's going to happen in the future, so they're very useful. So the scientific method is not a strict set of rules, do this, do this, do this, and this will happen. It's an approach to learning about the world around us. So this chart here is an attempt to explain what's going on. Often we'll start with an observation. From the observation, you make a hypothesis. Hypothesis gets tested through experiment. The results of that experiment may confirm the hypothesis or may cause us to revise the hypothesis. That happens enough and your hypothesis gets confirmed enough, it can become a theory. The theory is also going to be tested by experiments and either confirmed or revised. And so we find ourselves going in these circles a lot. Observations can lead directly to laws. Laws are tested. They're tested by experiment and confirmed or revised based on the results of those experiments. Any questions? So in your textbook, there are problems that are worked out, and then there are these conceptual connection questions, and I will go over some of these in lecture. So this one on laws and theories. Which statement best explains the difference between a law and a theory? So I'll read them and you pick your answer, A, B, or C. A law is truth, whereas a theory is a mere speculation. B, a law summarizes a series of related observations. A theory gives the underlying reasons for them. C, a theory describes what nature does. A law describes why nature does it. So what's the correct answer? B. The law says what happens. The theory says why. So C is exactly backwards. So the correct answer there is B. Let's see here. Changed my color scheme, so I have to change my colors on my markers. Okay, so that's the correct answer.